Okay, good evening or rather good afternoon. Before going to start, I have one query. Like Bikiran Soikia and Koila Singha, have you registered for this course?
No,
Yes, sir.
sir.
So who has?
মই কৰিছো register.
Koilas. Okay. So
Sir, I have not done.
all right. Now that's okay if you have
Sir,
not
I
registered.
came to know about this course
Uh,
yesterday, so I joined the group chat and joined the class today.
no, that's perfectly all right. But you have to give me your Gmail ID. Otherwise, every time I have to keep on adding you. All right.
Okay,
So
okay,
just
okay, sir.
submit your Gmail ID. And Koilas, are you using a different Gmail ID?
Sir, বেলেগ এটা দি কৰিছিলো.
Okay. So I will need this email ID as well because I have to add, na? That's why. Okay. Zahid Hassan Chaudhary. Same. Zahid.
Yes, sir.
Uh, I think you are using a different Gmail ID.
Yeah, yes, sir.
Okay. Just send me the new Gmail ID once in my WhatsApp.
Okay.
Sir, can I send my Gmail ID in the WhatsApp group, sir?
Yeah. Okay. হয় ছাৰ আপুনি মনত পেলাই দিলোঁ আৰু এতিয়া কৰক ছাৰ আমি আছে ষ্টুডেণ্টবোৰ okay so all right so the coordinator TEQIP coordinator of Assam Engineering College Dr. Pradeep Baisa sir will join us and just brief you regarding this course and after that we can start. So as soon as sir joins our program will get started. Okay, I've called him, he's joining shortly. Sir, good afternoon, sir.
Yeah. Good evening,
Good
Guti.
evening, sir. Good evening. Good evening. So,
Reading,
welcome,
sir.
sir. Thank you for giving some time to this course. And students, he is Dr. Pradeep Baisa, sir, from Mechanical Engineering Department. He is also the TEQIP coordinator of the entire institute, Assam Engineering College. So, since this course is under TEQIP program, and also somewhat like 3D printing is related more towards the mechanical engineering students, or nowadays in most of the areas it is used. So I think he will be the right person to start with. So, sir, can you just tell something
Yeah.
and inspire the students a bit about this
So,
course?
yeah. all, I would like to welcome all the students to this course on 3D printing and design, which is scheduled from today till 8th of February. So even though it's a vast thing, it's a vast course really to say that 3D printing and design. So it won't be possible to learn all the aspects within this short span of time. But even then, I think you are very lucky to have a coordinator like Vibhuti, who is very sincere. So hope you can grab maximum from him. And regarding the course, the 3D printing, as I can see from the list of the participants, that most of you are from the junior semesters. So it will be really very helpful for all of you, because why? Nowadays it has become these 3D printing and many other courses, it has become a part and parcel of your engineering course actually. Because later on, what will happen if you are not having knowledge of these things, you won't be having that interviews and all. Because nowadays, when the companies and the other PSUs, they come for the interview, they first of all ask these things. Apart from your core knowledge, whatever extra you have, whatever extra knowledge you have. So that's why your 3D printing and many other courses, robotics and many other things are there, which has become very much essential as on date. And as you are in the junior semesters, you will get enough time to have a thorough knowledge of these things. Because within this time frame, I think Vibhuti will be touching the main aspect. That means how you can move on with this software and all. But the major things will come to you once you are practicing it on your own, right? So that will come once you start practicing these things, okay? And the real magic behind the 3D printing is that you are actually manufacturing the things in sort of layers, right? Suppose, let us give a small example. Suppose you want to create a model where you are having 10 number of balls which are hollow and one inside another. So that you cannot think of manufacturing unless you have these type of technique, right? As it's going on layer, so what will happen? In the first layer, the outermost part will be there. In the second layer, the outermost and the second one. In the third layer, the next one. So that way, it will be manufactured in layer. And once you finish up with your manufacturing, you will be having that model. Just a small example I'm giving you. So there are so many models and other things which you cannot imagine to manufacture without this 3D printing nowadays. Previously, these things were almost, it was impossible. Right? So, but after coming of these things, it has become very easy. Just you need to, suppose you are designing some, suppose I think many of them are from mechanical also, right? So nowadays you just think of, imagine that of a vehicle, suppose, right? Any suppose passenger vehicle, nowadays you can see the dashboard. The dashboard, you are having a lot of features in the dashboard, right? So it's being changed very frequently, right? So many features are being incorporated in those dashboards. So those things, how you can manufacture at the very beginning. Initially, you make the design in your computer, right? Using some designing software, you made the design. But unless you have a manufacturing system, just like a prototype, you cannot see it physically. Yes or no? So that's why these tools are really very important. Okay, so once you have made the design, you can very easily convert it to a physical model. Previously, it was a very tough job. Even though you design it, then for manufacturing, what you require? You require a mold. That too is very, very expensive, right? So once you create the mold, okay, you created the mold, and after manufacturing, you saw, okay, we need to make these changes. Okay, so then you cannot go back and create another mold. Okay, so these are some of the aspects where your 3D printing and design, it has become sort of a magic for you, magical tool, you can say. Okay, so I just want to make all of you say to all of you that please try to grab maximum from these course. Okay, you just take it as the very basic course so that you can have it as a foundation course. Okay, so later on you have to build on this course, right? So without making much of a delay, I would just like to request Vibhuti to start with the course, and all the best to all the students as well as the coordinator Vibhuti. So he is very friendly person. So you can just ask him any questions. Okay. So try to learn as much as possible. So thank you, Vibhuti.
Thank
Thank
you,
you.
sir. Sir, sir, one second, sir. I would like to take this platform, use this platform to request you one thing, because this is an online course. So I think the
Right.
institute has one 3D printer of its own, if I am correct, right, sir?
Yeah. Yeah.
So if one
Right.
day, if the interested students, they can be demonstrated, then it will be very beneficial for them, because whatever they will be learning in this course, everything will be just in the, will be learning 3D printer in two-dimensional
Yeah.
screen, right,
Right.
sir?
That's
So if they learn
right.
3D
Right.
printing in
Right. Right.
three-dimensional screen,
Exactly.
then it will be better. For at least one day, they can be demonstrated.
So
This is a request, sir.
So that will be in online or physically they will be coming to AEC. That will be in online, I suppose.
Sir, hello.
No, you require the 3D printer to be
Yeah,
shown online or physically there is the
the
student.
interested students may also come if it is okay. Is it possible, sir? Some students may come, or others
Okay.
can be like shown the video.
So let me discuss because that is in the multi-skill.
Yes, I know, sir. I know, sir. Uh,
Right. Right. Right.
so
Okay.
just
So
a request, sir. If you can initiate the process, then it will be very beneficial
yeah.
for them.
Yeah.
Okay. So thank you again,
I'll
sir,
try.
so
Definitely
much.
try my best.
Okay,
Yeah.
sir. Thank you, sir, for taking time out from your
Thank you.
busy schedule.
Thank you, Vibhuti.
Okay. Okay, sir.
Okay.
And thank you,
Bye.
sir. Bye. Okay. So, students, one more students have joined. As Rajdeep Das. You have to also send me your Gmail ID. All right. So, okay. Let's start. So my screen is visible to all of you.
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
All right.
Yes, sir.
So this 3D printing course, 3D printing and design, this has been organized, of course, by Assam Engineering College, but you know, it is sponsored by TEQIP, and this is possible only because of NASCOM. Because NASCOM, it's like an initiative. NASCOM is a group of companies who have initiated this process, this type of programs, where different skills, new skills, or rather it's called future skills are imparted, will be imparted to the students in phase by phase. So 3D printing and design is my part, because I have been trained in this area, and not only me, but along with me some other faculties also were trained by NASCOM in collaboration with some IITs, and they were trained in some different area like robotics, artificial intelligence, Internet of Things. All are very new, and like very much significant when it comes to future skills. Okay, so just to start with, this is our schedule. So today the inaugural speech has already been given by Dr. Pradeep Basu sir, and we will also discuss the significance of this course, then the overview, and we will also see, or I will simply demonstrate the different softwares which are used in this process of 3D printing. The details you will learn later on. Okay, and in the last I will just develop a simple 3D model, and we will see how these things are processed using different software. Alright, so this schedule I think everybody has got. If you have not received, just let me know in WhatsApp, I will send. So this NASCOM, as I said, this an agreement, or we can say MOU, was signed between Central Government of India and this National Association of Software and Services Companies, shortly called NASCOM, to promote future skills platform. So it was started in the year 2018 to 19th February, and the objective was digital empowerment of youth, and it's a major initiative towards our Prime Minister Narendra Modi's dream, Digital India. So these things are going parallel with this dream of Digital India, and because of that there will be many benefits. First, it aims to skill and upskill around 2 million technology professionals and skills another 2 million inherent employees and students over the next some years. So it was MOU was signed in the year 2018, yeah, and so in this last 2 years already more than 50,000 students have got benefited. They have got skills, and what are these skills? These things are also decided by Central Government of India. So I will tell you what are these skills and how 3D printing is a part of it. So basically, with the arrival of new technologies such as artificial intelligence, blockchain, IoT, reskilling of young professionals is critical, because you see, when I took the engineering graphics class to the section D students, I was already emphasizing on learning AutoCAD, because knowing how to draw an parabola and ellipse in your chart paper, it's not going to help you significantly, okay, apart from getting marks in your end semester examination. If your only aim is to get marks, then it's okay, you don't have to learn any kind of skills. But when Pradeep Basu sir also just told, when it comes to placement, they always tries to see like what are the other skills that you inherit. Are you only limited by the knowledge of the curriculum, or you have like this passion of learning something extra out of the curriculum? So when you go out, okay, when you go out, suppose you have joined one design firm. I am a civil engineer, that's why I am taking the example of this. You have joined a design firm where, suppose you are a mechanical engineer, then also suppose you have joined a design firm where different parts and components will be designed. Do you think these things are designed on chart paper? No, these things will be designed in AutoCAD, or there are many software, 3D Fusion 360 is there, Solid Edge is there, so you have to work on there. So suppose that firm, that structural design firm or the machine design firm, they come to college and they are taking interviews, okay, then which two students are there? One is having like the best possible grade in all the semesters, but he doesn't have any clue about this software AutoCAD, okay, he is an expert in engineering graphics on chart paper. And the second student, along with the grade, okay, he also knows AutoCAD. So obviously he will be given preference, because why a company will hire you and again use their resources to train you in AutoCAD. You are getting my point? They have to again train you to teach AutoCAD. You're there, it will take say around 1 month, 30 days. So for 30 days they are simply investing money on you just to know a software which is already known to other people in say different institutes. They already know, isn't it? So that's why learning this type of software, learning this type of skill becomes very crucial when it comes to recruitment and during placement. Okay, so these are I think 9, 1 2 3 4 5 6 7 8 9, yeah. So these 9 skills, they call it future skills, are listed by NASSCOM and Central Government of India. So these are artificial intelligence, virtual reality, robotics, Internet of Things, big data analytics, 3D printing, cyber security, cloud computing, and then social and mobile. So many faculty were trained in these 9 listed categories. I think some of you have already completed one course on robotics by Juan Chaudhary from Mechanical Engineering. Okay, so again parallelly from today 2 other courses have started. As far my knowledge goes, it is I think one, yeah, Internet of Things by Subhrangshu Shekhar Malik from the Mechanical Engineering department and Kamini Kumari from Electronics department. They have started this course, Internet of Things. So this type of courses, when it is floated, it is for your benefit only, and try to attend this type of courses, because you will be getting one certificate along with it. Now coming to this portion, okay, certificate part. Many of you have joined without enrolling. So why this enrolling is important? So the thing is, the certification part will be done by NASSCOM. How? They will take one exam, I think 2 exams, one is called midterm, one is called end term. So this midterm and end term examinations, when you complete, okay, with good score, maybe 50% or whatever the cutoff, I don't know, then you will be issued a certificate by NASSCOM directly. Okay, Central Government of India and NASSCOM, and that certificate will obviously have a very okay, so that certificate will of course have some like very good significance. Okay, but what we can provide to the students who have joined without enrolling is one certificate from the institute. That will be just a participation certificate. We will not say that you are an expert or you are not an expert. We will not make any kind of that comment. Simply we will state that this person has participated in this course, and that's it. Okay, so the first, just to the second certificate everybody will get, whoever joins everybody will get, unless and until you have attended all the sessions regularly, because I will be keeping a track on this. Okay, although I am very liberal, okay, during my normal classes, you can ask your civil engineering friends, I don't believe in taking attendance. I have never taken attendance. If you are interested, you will be welcome. But since we will certify that you have participated, for that reason I will have to take attendance. Alright, so that is how you will get the second certificate. And the first certificate, which is the most important one, that's why it's called certification course under NASCOM. For that you have to appear one exam. Now after 3 years of experience in AC, I am sure that after getting the second certificate you will not even bother to sit for the exam, right? So you will be like, okay, one certificate is enough. So that's why I have decided that until you sit for the exam you will not be given the second certificate. It will be there, you will definitely get, but you have to sit on the exam. Whether you fail or pass, it doesn't matter, but you have to sit. Once you sit for the exam, the second certificate will be automatically handed over to you. Okay, so that is the deal. So out of these 9 listed categories, we will be focusing on 3D printing. So what is 3D printing now? Any idea? 3D printing requires a 3D model. Suppose this is a printer, a 2D printer, and this can print any 2-dimensional objects, even in the colored format. Okay, and for that you have to enter your input in 2-dimensional format. The fonts, the photos, all those things are 2-dimensional. Okay, so for 2-dimensional inputs you already have many softwares, right? In Photoshop you can design or anything related to photo. Okay, in Microsoft Office, in PowerPoint, MS Word, MS Excel, you can enter or give input to many things which are 2D in nature, 2-dimensional in nature, and from this 2-dimensional input it can give 2-dimensional output. But 3D printer, which will look like a box, of course this is a box too, but here this nozzle which like will eject the material. There are different types of 3D printers, we will discuss this, but initially just think like it's a pen. Okay, a pen will be there, and from the tip of the pen, the nozzle, some materials will come and in the liquid form, and it will get solidified. So this nozzle has to move in 3 dimensions. Okay, in X, Y and Z direction it should be having those kind of degrees of freedom, right? So now in order to print something in 3-dimensional format, we have to first give the input in 3-dimensional format, then only the computer will understand how it looks. Simply if you suppose provide the front view of this diagram, okay, and you want to draw a figure, a shape like this in 3-dimensional, will it be possible? No, because the computer will not understand how it changes in the y direction, right? So that's why we have to learn some software which can model objects in 3 dimensions. Nowadays fourth dimension is also coming into picture, especially during in civil engineering. Suppose a building is developed. Okay, a building is developed. What is the 4th parameter in 4th dimension? Can anybody say? X, Y, Z. What is the 4th parameter? Am I audible?
Yes, sir.
What is the 4th parameter in 4-dimensional world?
Time. So time.
Time. Okay. So suppose a building has been developed. Okay, it has been developed in 3D. Now the building will get constructed over a period of days. It cannot get constructed directly at one go, right? So it will be constructed like over a period of say 6 months. So during this 6 months, how the shape of the building will change, that can be provided as input. That means on day 1 what will be the how the building will look like, in day 2 how the building will look like, in day 3 how will it look like. So like that, if you go on the 180th day, how it will look like will be the complete the model of the building. So this is a 3-dimensional building, but how it is changing over time, that can also be inserted, and it can be fixed as memory of the software. So that's called your 4-dimensional modeling. So let's come back to 3D, forget 4D. Now this 3D printing process, there are different types. Okay, these are the like headings. If we say, these are the different headings which divide these types according to the like process by which the object is printed. The modeling part will be same. What you are going to model it using some software, if you are going to develop some model in AutoCAD, that part will be same. But after developing the model, how it will get printed, okay, that thing is different for different printers. Just like laser printers and inkjet printers, you understand the difference. Inkjet printers are the ones which like very slowly the paper comes out. Laser printers are very fast, right? So just like that kind of difference, there are some difference in different 3D printing processes as well. Okay, so these are actually hyperlinks. So I will click and the YouTube videos will get played, so that you get a visualization of what is the technique actually. So the first technique is called material extrusion, and under this subcategory is only one, which is called FDM, fused deposition modeling, or FFF, fused filament fabrication. This is the most commonly used 3D printer in the world, because this is also very cheap. Okay, so let's see how it is done. So these things are formed layer by layer. Okay, the arm can move in 2 dimensions, and once one layer is complete, it will go up and the second layer will be deposited. Okay, just like this, it is going. So there are many aspects to it. Okay, now one thing I wanted to show you, this these things, can you see some kind of net sort of things are there? These are not part of the actual model. These are called support materials. Now why support material is required, you will understand. Suppose this you know object, this object has this spikes at the middle portion. Okay, this spikes at the middle portion. That means I am talking about the depth. Okay, suppose this the depth of this object, the height of this object is say 50 mm. Okay, is 50 mm, and this spike is hanging midway. That means exactly in say from 2 to 3 centimeter of its height or depth, these spikes are coming and joining. That means it should be hanging in the air, right? It should be hanging in the air. But if the nozzle tries to print it like this, then what will happen? It will come from the bottom, isn't it? This is the top view, so it is coming from the bottom. So when it is coming from the bottom, and it for the first say 200 layers, if the layer thickness is very less, up to this height, for the first 200 layers, these spikes are not present. Are you able to visualize? These spikes are not present. The spikes are present only from a height of this. So if the arm ejects the material from its nozzle, then automatically it will go down and get deposited on the surface. So how it will hang? So because for that some support structures are automatically formed. You will see how the support structures are formed. So those support structures can later be removed. They are very weak, and they can be removed just by pressing the material, and it can be pulled out very easily. Okay. This is support material. See, that's what I was trying to say. The spikes are at the middle, so that's why the base was there, and from the base some some supports were there till this slab. You have seen building construction, right? During building construction, so during building construction, you must have seen how the slabs are constructed. The slabs cannot hang in the air directly like that. For that we have to give some kind of support from the ground, right? So just like that, some supports have to be provided to form this structure. Okay. There is one more video. Let's see that.
So you want to get into 3D printing. Well, that's fantastic because 3D printing is awesome, but you're not sure where to start. You're like, oh my gosh, there's so much information out there. What kind of 3D
These are called support structure. So you see, this is like a overhanging portion. So these overhanging portions, this has to obtain some support from the ground, and that's why these support structures are automatically formed. The printer will automatically, you don't have to model this portions. Simply if you model this face now, automatically when you print it, this support structure will get generated. We will see how it's done. these things are very important. This printing time, nozzle diameter. So the you see, the lesser the nozzle diameter will be, your object will be coming out very smooth. Okay, so that's how these things are. You see. So you see, that was the first and the cheapest method of printing in 3 dimension, which is called FDM, popularly known as FDM, fuse deposition modeling, because the material is fused and it is deposited. We will see in details how it is fused and deposited, but that is the method which is known as FDM. The second method is known as fat polymerization. So here, instead of okay, actually this is how an FDM works. There will be a roller where a very long wire will be rolled, just like your electrical wires. Those wires will be rolled here, and that wire is connected to this nozzle. So what happens when this portion is heated? Okay, when this nozzle is heated, then automatically the wire gets melted. Okay, it gets melted, and when it gets melted, it becomes liquid and it can be deposited through the nozzle. And when it gets deposited, it can be given any kind of shape. Okay, so when the when it goes upward, when the nozzle has done its part in that particular layer and it goes up, then that particular layer will get solidified because it will come directly in contact with air. Okay, so that's how these things are done. This is the product, and ultimately it will go up. So you see here, a spool of filament is located into the 3D printer. So this is the filament and fed through a printer nozzle in the extrusion head. The printer nozzle is heated to the desired temperature, whereupon a motor pushes the filament through the heated nozzle, causing it to melt. So it will get melted. Okay, the printer then moves the extrusion head along with specified coordinates, laying down the molten material onto the build plate where it cools down and solidifies. So here we are seeing the front view, but actually in the top view, what will happen? The top view, this nozzle first it will move in the XY coordinate like this. Okay, like this. Then when the entire thing of that particular layer is done, then it will move up, and these are nothing but layers. Okay, these are nothing but layers. Okay, got it? So once a layer is complete, the printer proceeds to lay down another layer. The process of printing cross sections. So basically cross sections will be printed one by layer, building a layer upon layer until the object is fully formed. Depending upon the geometry of the object, it is sometimes necessary to add support structures. I was talking about the support structures. For example, if a model has a steep overhanging parts. So here if you see this portion is protruding out. So if the nozzle tries to draw something here, it will automatically come down. Okay, so for that some support has to be formed. So these supports will be formed when, suppose here I am talking about this layer. Okay, I don't know if I am talking about this particular layer. So when this particular layer is drawn by the nozzle, So along with the actual structure, one drop will be left here also. Okay, one will be left here, one will be left here, one will be left here. So when this actual object is being built up, the support structures are also getting built up. Okay. So in this process, the material used is thermoplastic filament. Dimensional accuracy is a little bit of less, 0.5%. Common applications where it can be used: electrical housings, form and fit testings, jigs and fixtures, and investment casting batters. These things will be discussed in details in your later classes. Just since this is the beginning and I wanted to give you an overview, that's why I just took this example of material extrusion process. So the second is fat polymerization, and in fat polymerization there are two types. One is stereolithography, which is very common, which is known as SLA. So after FDM, the most common type of printer is called SLA, stereolithography. So here in both these two, digital light processing and stereolithography, here liquid resins are used. Okay, liquid resins are used, and using some kind of laser, those liquids are solidified. Okay, those liquids are solidified, and it goes from not bottom to top, it goes from top to bottom. The main difference between these two is that in stereolithography, the laser strikes at one point at a time. So in a particular cross section, it will strike at one point at a time, and in DLP, the entire the cross section will get the stroke of the laser at one go, and it will get solidified. Let's see how it's done. Okay. This is SLA, the first one.
Once the liquid thermoset resin is loaded in the vat and the digital instructions are programmed, the laser unit directs an ultraviolet beam to a reflective mirror. From there, a galvomotor system steers the focused beam to the resin surface.
So this green object, you are saying this is a liquid. So the liquid layer is first laid. Okay, first the liquid layer is laid, and depending upon the cross sectional shape, if we cut the portion of the object at this height, it is having a rectangular shape. So only this rectangular portion is it gets the stroke of the laser, and when it gets the stroke of the laser, this liquid gets solidified to solid. Okay, so this layer gets finished, and when this layer gets finished, to get the second layer, again the liquid will come from the box and another layer will be laid over this particular shape. Okay, just again see from here.
Once the liquid thermoset resin is loaded in the vat and the digital instructions are programmed, the laser unit directs an ultraviolet beam to a reflective mirror. From there, a galvomotor system steers the focused beam to the resin surface. First, the laser draws layers of the support structures, followed by actual part geometry. After a layer is imaged on the resin surface, an elevator system shifts the build platform down, and a recoater blade moves across the platform to apply the next layer of resin. The process is repeated layer by layer until the build is complete. Need quality 3D printed parts? Get an instant quote today at Proto Labs.
Okay, so let's see the second process, DLP.
Coming up, Ember 3D printer. That's right, today we're taking a look at the Ember 3D printer. Light. The projector shoots projection to, so this print is completely different than we've been doing. So this printer uses a DLP projection to cure photosensitive resin using a UV light. The projector shoots UV light as one full slice for each layer, and this can print in resolutions of 10 microns. So the metal build plate moves up along the Z-axis and prints emerge from the resin tank. The Ember printer uses a...
You see, this is moving upward. Okay, the nozzle is like in earlier case, what you have seen during FDM, the object was getting printed from bottom to top, but here it gets inverted and it is formed like top to bottom. Okay, so
cure and peel technique, this is where it exposes and separates for each layer to create.
So in FDM the base plate remains constant and the nozzle goes up. Okay, so here is like the base plate, you know, it goes upward. Okay, and there is no nozzle because it gets some kind of infrared
a high definition part. So when the UV light is exposed to the resin, it's hardened and solidified. The resin tank then separates and moves away from the build plate and then returns for the next layer. And this does this for like any support material, STL model material. STL models themselves are going to get prepared using Autodesk's mesh mixer, and here you can set up your support structures to hold onto the models to the print head. So setting up the proper orientation for an object.
You see, these are support materials. This you don't have to model in AutoCAD or any modeling software. The printer will have its own software or some open source software like Slicer and all those things are there. These support materials will get automatically developed by that software, so you don't have to worry about it, because it also depend upon the orientation. Okay, so it plays a crucial role when it comes to the orientation. So you as an engineer you have to decide, because printing something and getting the output will depend not only on the shape that you have developed on CAD, but how you are printing it on the printer. Using the same printer, if your orientation is different, then of course your quality will vary. Okay, these support structures, when they are removed, they leave some kind of marks on the surface. So you want to minimize the support structures. So when you want to minimize the support structure, so what I would have done here, I would have like rotate it this way. Okay, the ring should have been rotated this way so that it is like laying as a ring here. Okay, then your support materials would have been minimized in that case. Okay, so
can be a little tricky. You'll want to test different angles to get the right orientation. You'll also want to keep in mind that parts are printed upside down. That's because the print plate is oriented that way when printing. So you can optimize support structures to print with the tighter hold by upping the tip diameter. Under the support generator options, you can update the defaults from 0.15 millimeters to 0.5 millimeters. And this is going to increase the width so it holds objects more firmly, making print fails actually less likely. You can also add your own custom supports here to accommodate for any overhangs. Next up, we're going to need to slice the website. Here you can microns and then adjust the exposure time to 3 points.
you can see the videos anyway by clicking on the links, because I will share the PPT with you. So but just by clicking on the link you can watch the videos. So the third one is called powder bed fusion. So in powder bed fusion also there are two types, one where you use polymers and the second one is where you use metals. So when you use polymer it's called SLS, selective laser sintering. When you use metals it calls SLM, selective laser melting. So let's see what is SLS.
Once the nylon material is loaded in the 3D printer and digital instructions are programmed, the print carriage moves across the powder bed as production.
So instead of the resin, okay, instead of the liquid, here their powder. So a powder bed is there. So the laser comes and the laser beam will go and strike the powder materials. When they strike the powder materials, the powder particles get, they are already solid, but so we can say they get attached to each other. Okay, they get attached to each other, and ultimately it forms some kind of solid substance. Okay, so just you can imagine, suppose your glass, okay, the goggle you wear, that if you break it, okay, if you crush it, it will get some kind of particles, right? So those particles, when they are formed again, they are like put by the side of one another, and they need some kind of extra source of energy to remain in that shape. So that extra source of energy is provided by this laser. So this is basically
Production begins. An inkjet array selectively applies fusing and
just you watch. I'm just coming.
detailing agents across the powder bed, and is then fused by thermal energy into a solid layer of part geometry. Powder is distributed by a material recoating unit, and the process is repeated layer by layer until the build is complete. Need quality 3D printed parts? Get an instant quote today at Proto Labs.
Okay. So that was SLS. Now let's see SLM. So these two are same, okay? Direct metal laser sintering, DMLS or SLM, same thing.
Once the metal powder is loaded in the supply container and digital instructions are programmed, the laser unit directs a high-powered beam to a reflective mirror. From there, a galvo motor system steers the focused beam to the powder surface. First, the laser draws layers of the support structures, followed by actual part geometry, which is sintered into the bed of metal powder. Pistons move the supply container up and the build chamber down, while a recoater blade moves across the bed to distribute the next layer of powder. Excess powder is captured in a collection container. The process is repeated layer by layer until the build is complete. Need quality 3D printed parts?
Okay, so the difference was, in one case the powder was polymer, in the second case the powder was metal. Then this is laminated object manufacturing. So on video you can see here.
Hello friends, welcome to my YouTube channel. Is a laser is joint, then prototype object sheet of metal. Now let's see how this process works.
by looking at the name only, you can see that it's some kind of lamination. So layer by layer, the cross section of that portion gets laminated, and it can, the second layer is applied and the second layer gets laminated. So most of these things are similar, so you may get confused with this one. So you can say, how is it different from the powder system? So it is almost similar, but because you know the difference in the technology involved, they can be classified as a different one, which is because their lamination is done instead of fusing it, okay, instead of just combining the particles one by one. So the layer is laminated, so that's how it's got its name, laminated object manufacturing. So when the expert will come to give lecture about these things, so maybe he will be the right person to discuss all these things in details. So I accept I am not an expert in this category. Just in the month of, I think, November, I got trained for 5 days only. So I will leave this part to the expert. And direct energy deposition, DED, let's see how it's done. So this is also like the first one, FDM. So the materials, now this will be metal, that materials will be coming through the nozzle and it will get deposited. In the earlier one, the actual filament, the filament itself got fused and it got melted, and it was like it got converted to liquid, and later it got solidified. Now here it will be like ink, okay, but instead of liquid, some kind of semi-solid particles will come and it will get so as soon as the metals are coming, and it soon reaches this portion where it has to get deposited, directly a laser beam will come and it will strike. So when it gets the stroke of this laser beam, automatically it will get, you know, stick with one another, and it will form a solid portion in that particular point. So these things are like continuously, two things are going on, one is deposition and one is stroking by the laser beam, and ultimately this is like FDM only. But in FDM, you know what happens, the materials which are getting deposited, that is nothing but some kind of polymers, okay, which can be rolled as electrical wires. So of course the output will be not that strong, okay, it will be nothing but plastic only. But in mechanical engineering, the gears and all those things, they cannot be built with plastic, right? It has to be melted by metal. So metal cannot be like melted at a very low temperature, such as in FDM the temperature goes around 200 degrees centigrade, because just to melt the plastic, that temperature is sufficient, right? But to melt metal, that temperature will not be sufficient. So that's why this is a different process, where the metals will come and it gets fused here. Okay, so you can see these are the main techniques or process types which are used in 3D printing. The most common is material extrusion, which is known as FDM, then fat polymerization, there stereolithography, SLA is the most common one, then SLS, selective laser sintering, and then it goes like SLM, DED, and the price of the 3D printer also varies like this. The cheapest one will be from this category and the costliest one will be from this category. Now can anybody tell me like what can be the cost of a 3D printer? What do you think? How much it will cost?
Upwards of 40,000.
35
Yes,
to
it is. I will not tell very cheap, but it is cheap because nowadays the printers, if you want to buy a 3D printer, the normal printers I am talking about, that will also cost, a laser printer will cost around 15 to 20,000. And when you go for printing, 3D printers, here you see 17,699 with all of those offers. And okay, so you see how cheap the technology has become. So if you are good in 3D printing, if you know how to develop models, you can start your own startup. Okay, the one-time investment will be the printer. I don't suggest this printer. You go for the ones which are in the range of like 30 to 40,000 at least. Okay, but that will be one-time investment, and just like you have to buy cartridge in a normal printer, here you have to buy those wires. Okay, those materials which are rolled and fed into the nozzle, which comes and gets melted, and ultimately this shape is formed. Okay, so yeah, so I was talking about FDM. In this case the printer was an FDM, so I was talking about the price. Okay, the price in FDM also, the prices will be different. So how will you know that which one is best? Now just by looking at these three objects, can you tell me which one is which product quality is good? The red, green, or the blue?
red. Green, I guess.
Red or green?
Green.
Green. Red.
Red. Red, sir. Red.
Why red? What is the difference between the red and blue?
Yes, well polished.
Sorry, smoothness.
Smoothness. Okay.
Yeah.
And why
And
do
the
you think,
icon.
why do you think this red is smoother than the blue one?
Because by looking at the icon,
No. How do you think it is?
precise.
Yeah, it depends on the numbers of layers. Okay, more the numbers of layers, more will be the smoothness. Do you agree? Here the numbers of layers are more. Height is same, 100 mm. So this 100 mm, if we divide into 100 layers, so one layer thickness will be 1 mm. So if you divide into 200 layers, so it will be 0.5, and if you divide into say 400 layers, the one layer thickness will be 0.25 mm. So when the thickness of the layers are more, you can see it will take this kind of shape. Do you agree? When the thickness of the layers will be less, okay, it will be like this. So which one will look smoother, one or 2?
Two.
Of course 2.
So, sir.
So that's why it depends on the numbers of layers. So now the numbers of layers, if you have to like increase, if you have to increase the numbers of layers, then automatically you have to go for something where the nozzle diameter is also very less. If more material is coming out from the nozzle, then you cannot control the thickness of the layers, isn't it? If the material coming is like this portion, then will you be able to make the layers like this? No, the layer thickness will be like this in that case, right? So what we have to look for is a smaller nozzle, smaller diameter of nozzle. And not only that, one more thing will be also there. What is that thing? Now if the numbers of layers are more, it also brings one more challenge. What will be that challenge? Can anybody tell?
Cost.
Time.
Cost.
Cost. How cost? Because ultimately the
More
materials
materials will be required.
you cannot say more materials. Okay, the materials, the weight,
So time
will be
consumed.
almost same, just the of course, but that extra material will be very less, let's say 1%. So that is not the major concern
Time.
here. Major concern is time. Yes. So as we
Time
know,
consumed.
that this object is completed layer by layer. So more layers means it has the nozzle in 2 dimension. From the top view, if you see, the nozzle has to move in all the possible like points twice, here 4 times, right? So 100 layers means 100 times, 200 layer means 200 times, 400 layers means 400 times. The speed of the nozzle will remain constant. How frequently the arm moves from one point to another, that speed will be constant. So if that speed is constant, so which one will take more time? Of course the red one, because it
Yes,
is
sir.
more. So that's the difference. You see, this is the nozzle diameter 0.4 mm, 0.8, 1.2, and you see the time required to print this particular object: 58 minutes, 1 hour 36 minutes, 3 hour 52 minutes. So almost 3 hours more than this blue one. But you look at the output. So that option you will be always having. If you are in a hurry, of course your quality will get compromised, isn't it? If you want to compromise your quality, then you can print with like less numbers of layers, so that will be okay. So your client has ordered like 100 models, okay, 100 numbers of this model. So you were as just like an engineer, you were waiting for the last day. So the last day you prepared this model on CAD. Now you have to print it. Then only you realized this thing. Okay, so when you have to print 100 models, say not 100, say 8 models, okay, and you have one night. So can you go for the first one? No, because for one model it will take almost 4 hours. So definitely you will go for this one. So 1 hour per model, so 8 hours. But look at the output, what you will be having. Are you getting my point, what I am trying to say?
Yes, sir.
So that's the difference. Okay, so yeah, so I also have some YouTube videos, some more. So how these supports are removed, you have already seen, but just let me show.
Hi, I'm Owen from SprintRay, here with another tips and tricks video. In today's episode, I'll be showing you how to remove support structure and sanding scratches effectively. Here are the tools you're going to need. A set of flush cuts, some small files, high grit sandpaper, some chapstick, and of course,
this model. So all those things you are seeing here, these are supports. Okay, these are supports because it has many overhanging parts. So just to build this overhanging part, these supports are necessary. So let's see
3D printed part.
supports are removed.
You'll start by removing the majority of the supports manually. Since this is a fresh print, you can simply pull these off. Work your way around the model and remove the easily accessible supports. Avoid the fragile areas of the print. You don't want to break your model while removing supports. Once you finish removing these supports, use the flush cuts to snip the rest of them. The goal here is to separate the support structure from the model so that you can pull it off as one large piece. Now that you've got the massive supports out of the way, you can cut the trickier supports with the flush cuts. Don't cut too close, as this may cause pitting, which may be difficult to remove during sanding. Once you've removed all the supports, it's time for sanding. Use one of the small files to sand away all these small nubs left over by the supports.
You see, after removing the supports, some kind of impressions and depressions will be left on the surface. So
Structure.
it has to be removed.
Sand in a circular motion in order to remove the nubs without leaving deep sanding marks. The goal is to blend the nubs into the surface of the print. Once you've finished, use the high grit sandpaper to blend the sanded areas. Next, you'll use the chapstick to mask the sanding scratches. Simply use your finger to apply the chapstick.
Next, I'd like to show. So you see how these things are developed in CAD. That is a different thing. And suppose you have seen an object or someone, say I want to model the face of, say, Sachin Tendulkar. Okay, I want to model the face of Sachin Tendulkar. So do you think you have to model it like using AutoCAD? I think I should show you the third video first. So Blender is a software. Those persons who are like involved in gaming, they know that Blender is a software which is used to develop the figures. Okay, the figures, the persons that you see during gaming, those persons, the faces and all those things, these are developed in Blender. So it's a very Herculean task and it takes time, lots of patience. So experts from that domain, they can create, face using Blender. So let me show how using Blender these faces can be generated. So I will fast forward the video. This is like from a game. This is a character, and this character is created using this software Blender. So let's see how do they do it. This is the final output. So how starts with a box, as simple as a box. Everything in Blender starts with a box. So you got the point anyway. So Blender is a software with which you can create faces like this, and of course when you are an expert in Blender you will be able to do it. But what happens to Sachin Tendulkar, who will create his face as it is? Okay, in Mission Impossible 4 I already discussed this with my 600 students. 3 asile na 4 asile? Anyone? Am I 4, where they were trying to print the face?
4.
Am I 4? Yeah. So
Fall out.
yeah. So there someone has to scan the face, and then it can be again converted to 3D object. So in that case it will be called scanning, and scanning in 2 dimension we already know, but how scanning will be done in 3 dimension. So for that the photos from all the directions have to be taken. So let's see how it's done.
About a month ago, we made this video, and as a result, this happened. Yeah, Elon Musk saw it, bitch. On top of that, and if you want to print our relationship to the next level. Hours of work and trials and tribulations that I did not participate in, but part of the team did and figured out. It is now time to scan my face by taking a whole bunch of pictures, then we can upload it into a program which is essentially going to make like a 3D version of my face that can then go to the 3D printer behind us and print my face. So I don't know how this is all going to turn out, but Jay's going to just start taking a bunch of pictures of me like he's paparazzi, and we're going to see what happens. I have to stay perfectly still too, right?
So no talking, no blinking,
No breathing, be dead. Here goes nothing. Now, how do we take this and turn it into a 3D printed version of me? Basically, we take the photos, we imported them into a photogrammetry software, say that 10 times fast. Unfortunately, the mesh or shape that we created captured more background instead of just me. So we had to remove all the extra parts, which gave us zombie me. This still had too many extra shapes on the surface, so instead of cleaning this up, we used it to create a base template from which we could create a final sculpt. From this point, we started sculpting and tweaking the face to more accurately depict my stunning facial features. And as you can see, I went from zombie to bald alien. So to make me look more human, we started adding in some of the finer elements like hair and of
So he is again using Blender. Okay, after importing that thing.
course, our final touch for Jay. And get it ready to bring. We're finished with the for Jay. And now that we're finished with the model, we import it into the 3D printing software and get it ready to bring Sean 2 into existence. It's a working title. I think something's wrong.
What are you doing? Okay.
Well, we should figure this out. All right, so the last thing you guys saw was this being printed, and then we had a little bit of an issue, and so we had to reprint the top part of my head separately, and now we're gonna try and attach them together to form one seamless head. I know this isn't ideal, but I really don't want to spend another 3 days printing my face again. Pop my head off. How's it look? Just looks like a little disc. Satisfying. Okay, the little we've removed.
Oh.
Whoa!
Okay.
Ooh, even see the hoop, the little hoop earring?
Oh.
Boom! Serious boogers right here. This is gonna take a while. I'll be back shortly. All right, folks, we've removed my giant cylinder boogers out from my nose, and as you can see, how's it look?
Doesn't look anything like it.
What? I mean, my lips are bigger than that.
Ugly.
Way better look.
Yeah, yeah.
Okay, it's far from perfect, but now, yeah, what is? Okay, see you later, Jay. All right, folks. So obviously we printed out.
Okay, so you can see the video anyway. So that is one option of scanning and then printing to get the ideal face and all those things. And what if we have some kind of assembly in the structure? So let's see how this assembles the different so here you can see about this item, this has different assemblies, different parts. So these parts need to be like printed separately and they can be joined. So why did I choose this video? Is because if you go there, they have uploaded the model. Okay, they have uploaded the model. So if you open this, you see you can download the files. You can download all the files. So once you see the other softwares that we are going to discuss now, then you can download the files and you can see how it can be used. Basically the CAT files, I will not say CAT files, the STL files are uploaded. So these STL files, during print preview, how it looks like, those things you can see. So okay, that is it. Yeah, now the civil engineers constitute like 50% of this participant list, and I know they are thinking, what the hell am I doing here? Because as a civil engineer, how these things are important, right? So we are slow, but we are going in this direction. Nowadays the houses are constructed using 3D printers, and of course when we are talking about house, we cannot make house of plastic. That will be a model. When you go to Central Mall, you see the model of the Central Mall or any kind of good building is shown there, but that is for architect. Okay, that is for architect, and architect can print the models using plastic, but civil engineers can't print the model with plastic, isn't it? So the material has to be concrete, right? So instead of that polymer, if we inject concrete from the tip of the nozzle and the arm, the entire 3D printer, if it is like scaled up to a very huge size, okay, then houses can be printed 3-dimensionally. And I am not talking about some hypothetical things. These are already being implemented in developed countries. See, this is
the idea of 3D printing our buildings is nothing new. Faced with a desperate need to construct more homes faster and in a more efficient way, countless innovators have found themselves drawn by the idea of being able to quickly print a structure, and have spent years trying to scale the technology. But for all their efforts, that 3D printed world has proven elusive, and many impressive prototypes have struggled to become viable for mass production. But things have just taken a massive step forward in Germany with the completion of the first ever 3D printed home to become fully certified under a national government's building regulations. The impact of this moment for construction and for the buildings we all use could be huge. With the promise of cutting waste, reducing time on site and addressing labour shortages, some see 3D printing as the answer to many of our world's challenges. Originally used for small-scale prototypes, advances in 3D printing have led to the creation of full-scale structures like bridges and homes, and even plans for mankind's first Martian base. But while 3D printed structures have appeared around the world, from Canada and the Netherlands to Dubai, which wants to 3D print a quarter of its new buildings by 2030, the technology is yet to take off as a widespread building technique. But the completion of this 3D printed house in Beckham, Germany is set to change everything. Developed by leading formwork and scaffolding firm Perry, experts 60 square meters of team is now working on the largest
disruptive products and
the video is there, you can watch anytime. So you see, it is not like when technology technology gets it comes to our lives, it is not limited to branches anymore. Okay, when it may start with the mechanical engineering students first, but ultimately we need objects right? When we need objects, we need parts, we need equipment, we need houses. We can be of any form, and engineers are the ones which build something. Okay, now the computer engineering students don't have to feel bad, but your role is also very crucial here, because what we can do, the other engineers, is only like modeling the object, which you can also do, but coding the movement of the arm and all those things will be dependent on computer science engineering students only, because they can only code how the arm will move, how the nozzle will move from one place to another, and that will come from robotics. Okay, now if we like to combine artificial intelligence with 3D printing, then also it can be done. Like from the mistake, the machine will automatically learn what not to do in the second go. Okay, like the orientation, which orientation will be best to print the object, which will require the less possible support structures. Now how to, like, calculate the support materials weight, the support material volume, all those things can be they can be correlated sometimes with artificial intelligence. Okay, so it's not like 3D printing, it's not like only for mechanical engineering students, it is for everyone. From electrical engineering students, they can print circuits and all. So the chemical engineering students, they can print different equipment which will be required in a chemical factory. So yeah, so that's why this workshop was open to everyone, not only to mechanical or civil engineering students. Okay, so did I finish this? Okay, so now let's come to the last slide of today's lecture. So what are the steps? Okay, what are the steps in 3D printing, and what are the softwares that are used in 3D printing that we will demonstrate today, okay, in this last half an hour. Okay, so the first one, do you have any other engagements after this lecture? I can see third semester civil engineering students, you have class test after this?
No, sir.
You had one, huh?
So that's for 29 morning, 11 a.m.
29 morning. Okay. So I can like overshoot. Okay. Maybe I will try to finish by 7, but maybe I can overshoot. But anyway, now coming back to this. Now this is the process. Okay. The first one is, of course, develop the 3D model. Now to develop the 3D model, there are many softwares. Okay, we will learn AutoCAD and SketchUp. AutoCAD, because AutoCAD is also used as
Sir, there's one more, sir, on shape.
on shape. Yeah, that's why I have written etc., because there can be many. There can be many, not one more. There will be hundred more. Okay, 3D model softwares, like it depends on you where you feel most comfortable. So AutoCAD, I will be in AutoCAD I will be teaching 3D, because you will be using AutoCAD for 2D also. The other softwares are used, most of the softwares are used like only for 3D purpose, but AutoCAD is the only one which can be used both for 2D and 3D. Okay, so AutoCAD 2D, many of you already know, so who know, they can skip tomorrow's class, because tomorrow's class I will be teaching only AutoCAD 2D. So I want to know how many of you are there who is like very new to AutoCAD, they don't know 2D also. Is there anyone?
Yes, sir.
Okay.
Yes, sir. Yes, sir.
All right, so I think 4 or 5 students, so only you 4 or 5 you can join tomorrow's class, and there I will teach AutoCAD 2D. But before that, I want to know, have you installed the software as requested?
Yes, sir. Yes, sir.
Yes.
Yes, sir. Yes, sir.
The latest version?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes. So others can simply skip tomorrow's class. You will not lose anything, because the third semester civil engineering students are already expert in AutoCAD. Okay, they in 2D, of course. So you don't have to come. You can study for the after tomorrow's exam. And section D students, do you need a class on AutoCAD? You have also done pretty well, so I think you should not attend, but if you are interested, you can join anyway. Alright, so AutoCAD, then Solid Edge, Fusion 360, all those SketchUp. And if we see our schedule, I have kept one lecture on SketchUp 3D design software. Miss Amrita Sabha, she is an architect, so she will take one class on SketchUp. So being an architect, of course you will be interested in designing a building. Okay, so the engineering students from other branches, you don't get offended. If you know how to draw a building, then of course you will know how to draw any other things. Okay, so anyway, actually on 31st of January I have one exam duty of CTET, so I will not be there, so I thought why to skip that day. Okay, so I requested her, she agreed, so she will come and she will demonstrate how to draw building from 2-dimensional figures. Okay, from plan view, how to develop a building, that means from the blueprint how to develop it. And I know after looking at that demonstration you will feel AutoCAD is tough, SketchUp is easy, definitely, but as I said, some limitations will be there in both the cases. So maybe you can like draw the 2-dimensional figure in AutoCAD, then import it to SketchUp, then you can generate the 3D file. Whatever is easy, she will tell, and accordingly you can learn. And now coming back to the demonstration of the softwares that are used in the other process. So developing the model is the basic thing, the first thing that you have to do. So Solid Edge, the mechanical engineering students, they prefer Solid Edge, but as I said, AutoCAD is also very convenient, you can use it, no problem. Fusion 360 is like brother of AutoCAD. Okay, they are from the same company, Autodesk. So I have Fusion 360 installed in my laptop, so I will simply show you how the interface looks, Fusion 360. So if you have created the ID for AutoCAD, na, I think in order to install the latest version you have already created the ID. So if you have the ID in Autodesk, then Fusion 360 also you can download. With the same ID it will work. So this is Fusion 360, a very heavy software, but okay. Okay. So this is how it looks like. You can, you know, construct something. It's slow, but anyway, so like that you can draw something. Okay. You can use after finishing the sketch, you can simply that happens, you know, when you don't use the software for a long time. This can be extruded. Okay, this can be extruded, and the same thing, if you see, this thing can be done in, you know, AutoCAD as well. Okay, just I wanted to show the interface how it's done. So this is like you know, 100% 3D software. You cannot draw 2D diagrams here. You have to draw 2D, but ultimately it has to be like transformed to 3-dimensional figure. Okay, so in AutoCAD we will see these things in details. So okay, let's stop it here. All those things, okay, these things are also there in AutoCAD. You don't have to worry. Even if you don't download Fusion 360, it's okay. In AutoCAD, this 3-dimensional objects can be easily done. So now, after developing the 3D model, next step is exporting the STL file. So exporting can be done in the same software. So whatever the software you use, let it be Fusion 360 or AutoCAD, there will be an option of exporting it as STL file. Okay, stereolithography file. That stereolithography file can be, now you don't have to like you don't have to worry that can be used only for this, you know, stereolithography option. No, that stereolithography file can be used in any of the 3D printing process. So that after exporting, I will demonstrate how exporting and all those things are done. So after exporting the STL file, now we need another software called Slicer. There are many software. Slicer is an open source software which is available for free. That's why I have mentioned Slicer. So using Slicer, you can give the layers. Okay, those layers can be decided in Slicer, and also you can generate a Z-code file. Now what is Z-code? Z-code files is not mandatory. If you want to print, it is not mandatory to have Z-code files. But here, how, if you want to see how your arm will move from one point to another, if you want to see that, if you want to simulate that process before printing it, then you can generate the Z-code file, and that Z-code file can be run, okay, that simulation can be run using a software called Chemotix. I am not telling that Chemotix is the only software, but as I said in Slicer, same thing, Chemotix is an open source software which is available for free, so you can download and use it. Okay, now all those things, and after exporting the STL file or using it slicer, this can directly be printed by the printing software. Now this printing software will come automatically with the printer, isn't it? Whenever you buy a printer, the driver CD comes where the software is there, which works only for that software. So for this company GrabCAD, they are generous enough to upload their printing software for free, so you can download this. Now where you can download all these softwares, I have given the links here. So if you go to slicer, automatically that page will pop up where you can download the software. Okay, you need Mac, Linux or Windows, accordingly you can download. Alright, so similarly for downloading slicer and chemotics is very easy, just a click away. But in order to download GrabCAD, you have to go through some kind of formalities. Okay, so if you go there, if you click on this GrabCAD print software download, they will ask you to sign up. So you simply sign up, you use your name, last name, then email, password. That means you have to create one account. Okay, location and all those things. Then what do you use your 3D printer for? So here you can choose anyone, hobby or something like that. So after selecting, you will get some kind of verification mail through the email ID, and you can mention Assam Engineering College if it is asked. I forgot what are the options that ask, but anyway, after that either your account gets created, and when you open it through your account, the downloading options will be available, so you can download the software. Okay, you are an engineer, you are smart enough, you should be able to do these things without any help from my end. Eta muk message di thakile moi kobo nwarim aru etu link click korila aha nai boli gole, because moi ketia install korisilu moi nije pahorilu. Okay, so now this is the process that I said. Okay, now let's use all this software and see how it is related. So one by one I will open all the software and will show you how it is done. Okay, so which software I have to open first? Slicer or chemotics or GrabCAD? Which one I have to open first?
Slicer.
But for that we need to develop the model first.
Yes.
So I have to open AutoCAD. Okay, I have the 2020 version. So if you have a lower version, it should be okay, but working in the latest version is always easy. Okay, working in the latest version is always easy. 2021 version will be even easier than the 2020 version. Okay, so আজি তোমালোকে ওপেন কৰিব নালাগে, আজি just চোৱা. Okay, so when I open it, ইয়াতে more these things, this mode is called 2D annotation and drafting. Okay, these options will be there. So when you go for 3D modeling, you have to click on 3D. Okay, but there is a problem. If you go to 3D modeling and you try to draw 2D objects, some your tools will not work, like trim, extend, all those things will not work. So it is always better to draw the diagram in drafting and annotation mode first, then taking it to your three-dimensional figure. But anyway, without 3-man extent, it doesn't, you know, if your calculation is good, it should not bother you. So let's start here 3D modeling. I clicked on 3D modeling. You see the tools have changed now. So the very basic thing is always creating my space. So here also I have to create my space in 2-dimensional only. So let's create my space here. MV setup, then N for no, then metric M, then full, the paper width say 300. Okay, so this is my top view. So here you see 2D wireframe and top it is written. Okay, so if I click on this, it will come like this. So let's click on top here. So any kind of object if you want to draw, suppose I want to draw a table lamp sort of thing. Okay, there is not much time. Can I take like 15 minutes more or half an hour more today? Is it okay?
Yes, sir.
Okay, so like if I want to draw a like table lamp sort of thing, okay, let's not go into much details. Forget about table lamp. Let's, since there is not much time here, so let's draw a pentagon and then extrude it. Okay, so the top view, in the top view, suppose I draw an irregular object like this. Okay. Irregular object. Say a wall is there like this. Okay, wall is there like this. Okay, so you see this portion should be trimmed, but if I click on sometime it works, I don't know why, but anyway, okay, if it works, that is good. Now this thing has been created in the top view mode, so it will be like this. Now I want to draw the entire wall, so in that case I can use the press and pull button and it can be generated like this. So this is in the 2D wireframe mode. So if I go to shades of gray, it will be like this. Okay, it will be like this. Okay, so if I demonstrate this, the support structure will not be formed, so I have to create. Okay, yeah, I can create one here. Let's do one thing. Let me draw a circle here. Somewhere here. Okay, and this circle, and let me draw front view. Hang marile raba. So আমার 8GB RAM plus SSD still hang মাৰিছে, hang মাৰিব নালাগিছিল। এই Fusion 360 মহা দিগদাৰ কৰে দে, এইটো খোলাৰ পিছত মানে কম্পিউটাৰটো কিবা হৈ যায়। ঠিক আছে দিয়া, মই এইটো থাৰ্ড ক্লাছত শিকাই দিম। কাৰণ এতিয়া মই ড্ৰ কৰিম কেতিয়া তাৰপিছত বাকি সফটওয়্যাৰ কেইটা ডেমনস্ট্ৰেট কৰিব আছে so let's move these things to my third class so there I will demonstrate okay are you there
Yes, sir.
so anyway it's 7 so tomorrow as I said only those students can join who doesn't know AutoCAD at all so I'll teach you the basics of two-dimensional because without knowing 2D you cannot draw three-dimensional figures so only those 4-5 students can join don't know AutoCAD at all okay so is it interesting 3D printing do you think so
Yes, sir.
it's interesting
Yes, sir.
it's very interesting
Yeah.
so the main trouble is like drawing and developing the model so once you create the model automatically the other things are not that much tough okay so 80% of the things is modeling and after that you have to decide orientation and all those things so that's a different issue anyway so okay then I will take your attendance here একোৱে কাম নকৰা নেকি let me browse simply the names okay attendance has been recorded and Bikiran Soikia, Koilas Singha, Zahid Hassan, Rajdeep Das and last one is some Saha, T Saha, who was T Saha? Tad little left some T Saha, anybody knows? Tada Saha, Talla
Tuhin Shah.
not to him some different
So it might be Tada Shah.
Tada Saha okay sometimes I can't recognize my own handwriting anyway these persons need to send their Gmail ID to me otherwise I cannot repeat the same drama every day okay inserting one by one everyone okay so thank you I hope you will continue the other classes as well thank you regarding the recordings
Thank you, sir.
Thank you, sir.
Thank you, sir.
but the recordings will not be shared now okay the recordings will not be shared now it will be shared after courses hello
Do I need to send the email?
email just WhatsApp me and
Yeah, sure.
okay bye